Today we will discuss the numerical portion in vibration engineering. The question is, determine the following for a vibrating system with viscous damping subject to harmonic excitation of 10 Newton. The mass of 11 kg is suspended by a spring of stiffness 1000 Newton per meter, and the damping capacity is 40 Newton meter. We have given in the question the force of 10 Newton and the mass of 11 kg and stiffness K is equal to 1000 Newton per meter. And damping capacity, that is denoted by C, is also given. We have to find first resonance frequency, phase angle at resonance, amplitude at resonance, frequency corresponding to peak amplitude or damped frequency. First of all, we have to find resonance frequency. Resonance frequency means the frequency at the resonance will be omega is equal to omega n, that the ratio of omega by omega n will be 1. We can see the solution, that the resonance frequency omega is equal to omega n. We know that omega is equal to root k by m. Value of k is given, that equal to 1000 and the mass 11 in root. Then 9.53 will be our answer. Second, phase angle at resonance. Phase angle at resonance means omega is equal to omega n, and the omega upon omega n will be 1. Then the formula is phi is equal to tan inverse 2 zeta omega by omega n upon 1 minus omega by omega n whole square. By putting the value of omega by omega n and zeta, we will get the value of phi phase angle at resonance. Next, we have to find amplitude at resonance. We know that the formula of amplitude is equal to f naught by k divided by in root 1 minus omega by omega n whole square, and the whole square plus 2 zeta omega by omega n whole square. We know that zeta is equal to c by cc, and cc by 2m is equal to root k by m. If we put the value of cc is equal to root 2 km in this formula of damping ratio, then we get the value of zeta is equal to 0.1906. By putting the value of zeta and omega by omega n in the formula of amplitude, we get the value of amplitude is equal to 0.22651 meter. Next, the frequency corresponding to peak amplitude. The formula of peak frequency is in root 1 minus 2 zeta square into omega n. The value of omega n we have already find out. There is the value of 9.53. By putting this value, we will get the value of omega p is equal to 9.179 radian per second. Next, we have to find damped frequency. We know that the formula of damped frequency omega d is equal to in root 1 minus zeta square into omega n. We have the value of zeta is equal to 0.1906 and the value of omega n we have 9.53 radian per second. By putting this value in this formula, we get the value of omega d, that is 9.356 radian per second. Next question we will discuss. The question is damper offer resistance of 0.05 Newton at constant velocity of 0.4 meter per second, and the damper is used with K, means the stiffness is given is equal to 5 Newton per meter. Calculate the damping factor and damping frequency. Here mass is given for 0.1 kg. We have to find damping factor, means zeta. We know that zeta is equal to C by Cc. And the damp frequency omega d. Omega d is equal to in root 1 minus zeta square into omega n. First of all, we have to find omega n and zeta, then we will get omega d. We know that omega n is equal to root k by m. By putting the value of k and m, we get omega n, that is equal to 7.07 radian per second. And the value of Cc by formula, we know that is equal to 2 root km, that is equal to 1.414 Newton second per meter. The damping force, that is equal to Cx dot from this. C will be equal to F by X. The value of F is given, that is 0.05, and the X 0.4. X dot is equal to 0.125 Newton second per meter, and the zeta will be C by Cc is equal to 0.125 upon 1.414 will be equal to 0.088. We get the value of zeta and omega n. By putting the value of omega n and zeta in the formula of damped frequency, that is equal to omega d is equal to root 1 minus zeta square into omega n. then we get the value of omega d is equal to 7.042 radian per second. That is our final answer. Thank you.